Welcome to the second kinematics equations problem. This is the second one. This is going to be a little bit more challenging than the first one. So a ball is thrown vertically upwards at 3 meters per second at the edge of a cliff. The ball lands 2.5 seconds later. How tall is the cliff? What is the final velocity of the ball as it strikes the ground? Um, and then what is the maximum height, and how much time does it take to reach that maximum height? Okay, and this ball is not thrown at an angle, so that's something we have to know. Okay, let's see how to solve this. So let's look at the ideas method. Let's first identify what we're given in this problem here. So we're given that the time that it takes for the ball to land is 2.5 seconds. So time, let me say this is a given. So specify this is a given. So these are the givens for this problem. Let's do that in red. So time is going to be equal to 2.5 seconds. So, and then the ball is thrown vertically upwards, so that's going to be the VIY is going to be equal to 3 meters per second. Okay. All right. Next thing is we have, okay. So yeah, these are the things that are given to us. Let's assume that this is on Earth. So this is going to be the acceleration in the y direction. It's going to be negative 9.8 meters per second squared. Another thing is, since we're looking at the max height, we have to worry about the max stuff as well. So the velocity that's going to be there at the max, right? The velocity at the max is just going to be equal to 0 meters per second. This is the I should specify, this is a vertical velocity at the max. Okay, the vertical velocity. And since this is actually just going to be, actually I don't need to specify that because this is going to be launched vertically upwards, so it doesn't have any x velocity anyway. It's just going to constantly be 0, and there's no acceleration in the x, so it's just going to constantly be 0. And so this ball is just going to go up like this, straight up, not even at an angle, and then it's going to go up like this. It's always just going to be vertically down like that. So initially there's no x, so there's no x at all, and it's just going to constantly be y, 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 y. Okay, just going to specify that. So I don't need to say that. So this is Vmax is equal to 0 meters per second squared. Sorry, 0 meters per second. Those are givens. Let's see what else I can look at for the finds here. So what are we trying to find? We're trying to find so many things here. Well, how tall is the cliff? So that's delta y. Delta y. We don't know that. Question mark. What is the final velocity? So this is the final velocity, let me tell you, in the y direction. Because in the x direction, what's the final velocity going to be? Well, it's going to be the initial velocity, and there's no initial velocity, so the initial velocity is going to be 0 in the y direction. Or, sorry, in the x direction. So it's just always going to be 0, so we don't have to worry about it at all. So if we just draw the velocity vectors, this would be pointing upwards, 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 stuff like that, and then it would be at one point it would be 0, and then it would go like downwards, downwards, downwards. There wouldn't be any horizontal component of this velocity because there's nothing going on in the horizontal direction since this is vertically upwards. Okay. All right, so this is it. These are the finds. Well, we have the T max, right? That's the time it takes to reach the maximum height. That also we don't know, and we also have the maximum height. So we'll just write that as delta y max is equal to question mark. So quite a lot of givens and quite a lot of finds. Let's go to the diagram step. This is the step to visualize what's going on. So let's go back to the problem statement. A ball is thrown vertically upwards. So let me see. At the edge of a cliff. So let's see that this is a cliff right here, something like this. And then there's a ball. This ball is thrown vertically upwards just like that, and then it's going to come back and land on the floor. Something like that. It's going to only have vertical velocity, and that's it. So if we were to draw the final velocity, that would be going down like this. So that would be like this. That's VFY. And V initial and I should say this is the it's thrown vertically upwards at 3 meters per second. So this is going to be the initial velocity in the y direction. Let me say this is going to be straight upwards. This is VIY. And then we have a couple more things. We have the height of the cliff over here, something like that. That's going to be delta y. And then we also have the velocity at this moment in time. That's going to be the velocity at the max, right? And that's just 0. This is equal to 0. Okay, it's a given. And then we have the height of this, which is going to be, well, that's going to be delta y max. Delta y max. Let me write this neater. This is going to be delta y max. Okay. All right. Yeah. So this, let me underline the givens and whatnot. So this is the finds. These are the finds. So find, and then the givens are these things right here. All right. This is the diagram step. This helps us visualize. Okay. Next we have the equation step. This is gonna have a lot of equations. We're gonna have equations, not in the x. So let me write that. And we're going to have it in the y, and we're also going to have some max equations. I'll show you that later. So let's look at the y. This is a final velocity in the y is equal to initial velocity in the y plus the acceleration in the y times time. The delta y is equal to the initial velocity in the y times time plus a half acceleration in the y times time squared. And then v final y squared is equal to v initial y squared plus 2 times the acceleration in the y delta y. Okay? Those are a lot of equations, but we're going to only be looking at a couple of these. So let me see. Let me underline, color code this. So this, VFY, and then VIY, T, acceleration, T, acceleration, and then this is a find. Okay, there you go. All right. So this is good for us because we have everything laid out here. We have all the information. We can use this equation quite easily right here. So this is nice. We're going to use this equation. This equation is also nice because we have everything we need. So this is also an equation we can use. This is nice, right? Next, we don't need this equation because we have 2 unknowns. We can solve for one and plug it in, but that's not necessary, so it's fine. Let's just get rid of this equation. We don't need this equation. That's the y. We have these 2 equations. Very, very nice. It's going to save us some algebra at the end. All right. Next, we have to look at the maximum equations. So max, I'm just going to write the max. Now, the max equations, there's going to be 2 equations that you need. But let's kind of derive these equations. So let's just say that the velocity final, instead of the velocity final on the y being the velocity as it hits the ground, let's consider that to be the velocity at the max position there. So let's just say that's v max. And this is going to be equal to v initial in the y, it's still being launched from this position, plus the accelerations y, same acceleration, and then the time, but not the time that it takes all the way, but the time it takes to reach the max, which is t max. This is our first equation. The second equation is going to be delta y max. Delta y max is equal to, and then we have the initial velocity in the y times time max plus 1/2 times the acceleration in the y times t max squared. Okay. Last one, v max squared is equal to v initial in the y squared plus 2 times the acceleration in the y delta y max. Okay, let's now use the color coding to help us choose our equation here. Okay, so we need, let's see, we have this, we need this, we need this, we have this, we need this, we need this, we need this, we have this, we have this, we have this. Okay, so let's now, so we have this, 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 and I forgot to do this one. Oh, I did it. It's right there. Okay. And next we have this, this, this. All right. Think this is right. Okay. Now let's look at this equation. This equation seems interesting because it's perfect for us. We have one unknown, and it's perfect. So let's use this one. This one has three. Well, it's two unknowns, and so this is one of those equations like this one where you have to plug it in. So let's not use this one because we can use this one right there. That's perfect. Now we have our 4 equations for our 4 finds, perfect for us. Let me go to the algebra step here now. So this video is getting kind of long, but this is an interesting video. It's kind of helpful to visualize. So this is equal to VIY plus acceleration YT. This is our first one. No manipulations needed whatsoever. Well, yeah, this one we don't need any manipulations. This is good. Okay. Delta y is equal to VIYT plus a half AYT. Same with this one. We don't have any manipulations, but for the max equations, we might. So let's see. V max, we will, is equal to VIY plus the acceleration YT max. So in the algebra step, we get rid of the zeros. This is a 0. This is just going to be a 0. This is gone. This is gone. This is a 0. And what else can we do? Well, we need T max. We need to solve for T max. So let's subtract VIY on both sides. So this is going to be VIY. This is going to go, and then this is just AYT max. Solve for T max, divide by AY. Dividing by AY. This will go. Whoops. We have what we want. Let me see here. Let me color code this just to make it more clear. So this, and this, and we have all of these things here. So this, no, not that, this and this, and we need to find this, and we found it. Last equation here is our V max. We have to, again, we can get rid of that. This is a 0. So this is just negative VIY squared over 2AY is equal to delta Y max. I just kind of wrote this quicker because I don't want to waste time. This video is kind of long already, so this is going to be the givens and the unknowns. So it might be kind of messy, but if you go to the solution step, we plug in everything. Let me just box in the equations so it's more clear in a different color. So this is equation 1 to find this unknown right over here. This is equation 2 right there. So the underlining can make it a little confusing to see, but here we see this as equation 1 to find equation 2 to find that. Then this is the equation 3 right here. This is to find T max, and this is the final equation, perhaps the neatest to write, to find delta Y max. These 2 equations, you can actually memorize them if you wanted to, just to save time, but it's not too much. It's not too bad to just derive them on the spot, and it's not too bad, honestly. So yeah, these are our equations. If you wanted to solve, you would go to the solution step and then do it on your own. All right, I hope you found this video helpful.